Problem 4, Part A. Find the surface area when the parametric equations x is equal to 2 cosines of t, y is equal to 5 plus 2 sines of t is revolved around the x-axis from 0 to pi over 2 for t. So surface area formula is 2 pi, and the integral from 0 to pi over 2 of 5 plus 2 sines of t, that's y of t, times the square root of the derivative of x being squared, which is negative 2 sines of t being squared, and the derivative of y with respect to t is 2 cosines of t, and you're to square that. You should be seeing that the sine squared plus cosine squared is inside that radical. So we're going to multiply it out and get 4 sine squareds of t plus 4 cosine squareds of t, factor out a 4, and we get the square root of 4 times sine squared plus cosine squared. And again, sine squared plus cosine squared is 1, so we get the square root of 4 times 1, which is 2. And again, we're not done, we're just setting up this integral so it can be solved. And so continuing, the surface area is equal to 2 pi, integral from 0 to pi over 2, the 5 plus 2 sines of t from before. That square root just turned into a 2. Distribute that 2 and get 10 plus 4 sines of t. Integrate, 10 is 10t. Integrate 4 sines of t is negative 4 cosines of t. Evaluate that from 0 to pi over 2, and don't forget your 2 pi out front, and you get 10 pi squared plus 8 pi. Part B. Finding the surface area, the same set of parametric equations as in Part A, except this time we're revolving around the y-axis, so we get 2 pi. Integral from 0 to pi over 2, 2 cosines of t, we get the same square root. We arrived at in the Part A, square root of negative 2 sines of t squared plus 2 cosines of t squared. That turned out to be just a simple little 2. So we now have 4 cosines of t inside that integral symbol. And we get 2 pi. Integral from 0 to pi over 2, 4 cosines of t, which of course is just 4 sines of t. Evaluate that from 0 to pi over 2, and we get an answer of 8 pi.